Hello everyone. So 6.3 introduces a new type of graph which is associated with our square root function. So we have our general parent function here. We have, since it's a square root function, we do see that it has a square root in it, so it makes sense. Our domain, well, if you think about what kind of numbers you can take square roots of and actually get numbers of, we can take the square root of 0 and get 0, and then we can take the square root of any positive number. Negative numbers were not defined, we're not graphing imaginary, so it kind of makes sense, if you think about it in that sense, that our graph is only going to be the positive x values, and then when we take the square root of numbers, we have positive numbers that come out, so we are present in the first quadrant for our parent function. Our intercepts, our x-intercept is 0, y-intercept is also 0. It's not defined for anything less than 0 because, well, we're not going to be taking the square root of negative numbers when we're graphing and talking about something real. And then our end behavior, as we approach right, we are going towards positive infinity, and as we are going up, we are also going towards positive infinity. Our general form should look fairly familiar. We have that a value that we've been seeing a lot, that minus h, which we have also been seeing, and as well as that k. All of these do the same thing as they normally would. A still deals if it's going to face up or face down, and its vertical stretch. The h is still going to look like the opposite and tell us our horizontal shift, and our k is still going to be the regular vertical shift. So constants that we've seen and we're familiar with, just applied to a different type of function. So let's take a look at identifying the domain and range of something. Well, typically you'll be able to just follow these two. Your domain is going to be every x such that x is greater than or equal to whatever makes your radicand equal to 0. So in this case we see, well, if x minus 2 is equal to 0, I know I've shifted 2 to the right, I'm greater than or equal to 2. For your range, so long as we are talking about a positive radical and not a negative radical, aka our a value is positive, we are going to be f of x such that f of x is greater than or equal to our k value. Since here there is no k value, there is no vertical shift, we are just greater than or equal to 0. Easy as that. Domain and range are going to be heavily based on that kind of starting point, this sort of like initial value, as well as whether or not the a value is positive. So let's graph something. Graph the function y equals 3 square root of x minus 4 plus 2, as well as state the domain and range. So let's graph first, and then we'll take care of our domain and range. Definitely want to know whether or not we're facing up or facing down. In other words, going like this, or going like this, as well as what that point is. Well, I look inside my radical, I know it's the opposite of what it looks, so it's going to be 4. Look outside, I'm plus 2, so I'm moving up 2. My square root function, which is going to be facing up, it's going to be that positive version, is starting at the point 4, 2. I've shifted 4 to the right, as well as 4 up. So 1, 2, 3, 4, 1, 2. Now, to figure out another point, I'm just going to plug in a number that will make this relatively nice. I know I can take the square root of a number like 4. So if I plug in 8, 8 minus 4 gets me that square root of 4. So I've got 3, square root of 8 minus 4 is 4, plus 2, 3 times 2, plus 2, I've got 6 plus 2. My y value at 8 is 8. And again, I just chose that because I'm looking to see, well, I want this to be somewhat nice. I'm already graphing a square root. I want to make sure that I get a value that is nice an integral so that way I can plot it on my axis. So I move over 8 and up 8. I can connect these 2 points, end up with an arrow. Notice how it's just going up. There's not 2 ends of it. It just kind of starts here and then kind of continues to the right. And I knew that I was going to go up because that 3 value was positive. So let's take care of this domain and range. Domain. So I've got x values such that x values are greater than or equal to, well, what made this thing 0? 4. I also see, well, I've got x values to the right of 4. Range. I've got f of x such that f of x is greater than or equal to, because I am positive, which y value is it here? 2. All you gotta do to graph these. Figure out where you're starting, figure out if you're going up or going down, and then just to get that shape, pick an x value that's going to make your radical relatively nice to work with. You don't want to take the square root of 3, don't want to take the square root of 7. You also don't want to plug in a number over here because you know it's not going to be defined over there. This function is going up and to the right, so I want to plug in x values that are to the right of that. And let's tackle an inequality. So, graph y is greater than the square root of 2x plus 4. Well, let's see what my x value is that I'm starting at. Now typically this would be fairly simple and just be like x plus or minus some sort of number. And whatever that number is does make that inside the radical area 0. So in this case, if 2x plus 4 is supposed to be equal to 0, looks like x is looking at negative 2. So I know that's my x value. I look for any sort of vertical shift. There is none. So I also see, since it is strictly greater than, it's going to be an open circle. If it was greater than or equal to, it would be a closed circle. But an open circle at negative 2. I've got to plug in a number that's going to make this fairly nice. I look and I see, well, if I plug in 0, 0 times 2 is 0. 0 plus 4 is 4. I can take the square root of 4. I've got a point there. It's going to be dashed. If I wanted to plug in a couple extra points to make sure that curve is just right, you're more than welcome to. So now I've got to figure out where I'm shading. To do that, just like usual, we're going to test the point. So let's test 0, 0, since it's not our graph. So is 0 greater than or equal to 0 plus 4? Is 0 greater than the square root of 4? Well, 0 is not greater than 2, so I know I'm going to be shading above. Now be careful, we know that we're not defined. You don't have to draw that line, that's just simply, a boundary for my own shading. I'm going to shade above, making sure I don't go any further left than my starting point, essentially. And once I don't need it anymore, I can erase that little boundary line for myself. It just kind of helps visualize, well, I'm going to be pretty close to that point, but not really hit it, since it is strictly greater than. And that's what our inequality looks like. That's pretty much it for 6.3. I shall see you in class. Have a good one.